So let's take a look at simple. And if you'll recall, let me bring it back up here. Simple is I'm drawing a square in the middle of the screen. I'm giving a physics body, and I'm saying it's static. So when gravity is turned on, or if I drag it, this body is not allowed to move. That's the key thing that you have to understand about a static body. Not allowed to move. Additionally, let me go back and reload this. All throughout the code for the doll, I have a function whose job it is to draw limbs. There's one for arms, one for legs. And what it does is it takes inputs to tell it how long the arm or leg is. And then what it returns is a rounded rectangle, which is what you're seeing here, which is the white part. And then welded to it with a weld joint is a circle on the left and a circle on the right. And the function itself returns a reference to the rectangle, a reference to this joint, to this object, and a reference to this object. And then having those three parts, I can use the information and say, I know where this position is, so I'll make the next arm starting over here. And then it just makes it easy for me to create these simple linkages. So we're going to demonstrate calling this once to create a single arm, which in this case is just this little bit here mounted to the static. You might want to mute your microphone there. It's, whatever's happening is taking over the camera too. Or Charles can take care of that. Sorry about that. All right. So anyways, let's take a look at the code. All the code's going to be organized the same. It's a composer scene, and you'll see my normal stuff at the top, but it's not the splash screen. I put the wrong comment here. We load composer, we create a scene, we load the physics library. I set up a bunch of variables. I like to set mine up at the top. There are some localizations, which means that I dereference some functions and put them into locals. Now, most of these I'm not actually using in this file, but I didn't want to delete them. I wanted to maintain the standard structure of this file. The important bit you're going to see will be not the create scene. The create scene for all of these examples creates the title, the buttons, and the background, but it does not create the block, it doesn't create the arm. That is created in the will enter scene method. Now, will enter is not a standard composer scene method. It's something that I wrote. Go down to the bottom of the file. I have the traditional composer show and hide methods, which then looks into the event and says, is this the will show or the did show? If it's the will show, call will enter. If it's the did show, call did enter.
And
the reason I
okay, go ahead. Yeah.
The reason I did this is because this is the structure that was followed by the previous one, which was what was prior a storyboard. Storyboard had the will enter, did enter concept, and so I followed that in Composer because it just was a nicer transition. I also like it because there's no question if you use my framework, where is it, and you put some code in the will enter, it's going to get executed when you are about to enter the scene, not when you did, or it's not going to get executed twice. People in the forums make this mistake. They use the show method. They don't look at the will or did part, and then they're surprised when the code executes twice.
Yeah, that is a confusing piece.
So if you use my framework, confusion goes away, as long as you understand what I've done. Okay, so what do we do here? First thing that happens is I start physics. You got to start physics before you can do anything else with physics. Then I set gravity to 0 because I want to start off with no gravity in this scene. And then I set physics to continuous. This is not necessarily what you don't necessarily need to set physics to continuous for this example to work. Physics being continuous is basically telling the physics engine to continuously reevaluate the relationship between the different joints and other objects with each other. It's a much more intensive application of the physics engine, and so you probably want it to be false unless you absolutely need it. In fact, I will probably commit this with all of these commented out, and the default case is false. And then if you run one of these examples and it doesn't feel like it's behaving properly, you may want to go back in and set that to be continuous. But I think that is, as I said, I derived some of this from some work that I did previously and made quite a number of changes and rewrote most of the code, but I left that in. So I will come back and talk about continuous versus non-continuous on a future episode. For now, it's going to be commented out when I commit this. Okay, one of the things we're going to be doing a lot in each of these examples, let me find the simulator again, is we're going to be creating display objects, and then we're going to be attaching physics bodies to them. However, when I'm making the draggable doll, I don't want these body parts hitting each other. So there's two parts to physics interactions. There is a collision detection, which is you can set up some code that detects whether or not a collision occurred. However, if you set up a basic physics body and you don't specify any details about filtering, etc., which I'll discuss in a moment, then every physics body will collide and respond with the other physics bodies. And what this means is if I had not done this group index filtering, and I'll talk about it a little bit more, what would be occurring here is all of these body parts would be hitting each other, and this doll would just be like wacko. In fact, let me see if I can just make this just show you what this looks like if I don't do this.
His forearm and his upper arm or whatever are rectangles, right? So they're at some point they're actually the angles are actually interacting with each other.
Yeah, these things are all overlapping each other.
Right.
At the joints. And you can see I'm not touching this at all, and it's just going crazy. What is occurring is these body parts are now they're hitting each other.
Why are you hitting yourself? Why are you hitting yourself?
Yeah. How are you hitting yourself? We turn on gravity, you can see the behavior is all wonky. Like the arms, the legs no longer loose. Oh, that was not a good kick. Oh. So anyway, what we want to do is we want to say, don't hit yourself. Don't allow any of these body parts to hit each other. And the very easiest way to do that is to create the physics body with a filter and then set this magical property, group index. Sorry, I forgot to turn off my ringer. Set the group index to -1. In a nutshell, what that is saying is all physics objects created with this filter will no longer respond to each other. They can still sense that they've collided with something, but there'll be no response. The response is the part where the physics engine says, now do something. And typically the response is, don't allow two physics bodies to occupy the same space. In other words, if you hit one, push it away, or at least keep them from overlapping. Does that make sense?
Yeah.
Okay. So I'm juking and jiving over here. So here's my filter, and in my code I set up one filter and I just use it over and over as I create the bodies. Alright, now the next bit of code. Let's go to simple. So here's our filter. Now I create a table which I created a reference to way up above in the code. So this is a locally visible variable visible below this point to all the code. And what I'm doing, it's not so useful for simple example, but it will be more useful later for the posing example. It's basically a table, and every time I create an arm or a leg or something, I'm going to put it in the table. So I have a big list of body parts. which is what it is. It's the body parts.